Hey everyone, we're going to get started in just a second here. Robbie from San Diego. Welcome, Robbie. Thanks for being here. We'll be doing our best to monitor the chat throughout. We'll have some Q&A at the end, so feel free to find some questions, get them prepped. Hey, Evan, thanks for coming. Those of you just joining us, we're going to take a second to let people filter in. I should be playing some music. Anybody want to sing? No.
No. By the way, can you hear me?
Yeah.
Oh, I didn't realize that.
Glad you didn't say anything incriminating.
I am not some other CEO. Sorry.
I'll get the Coldplay going.
Right time.
Hey, Tristan. Thanks for being here. Where's everyone calling in from? Most of the Flyte Union folks are out in Bellevue, Washington, just east of Seattle. Normally, I'm in New York. Colombia. Hey, David. Evan from Germany. This is an international crowd. Sweden, India, SoCal. Go Dodgers. New York, SF, Brazil, scorching Las Vegas. Just getting cooked alive. Keithon, are you rocking the new Flyte tee?
I am.
I know. Look, I know modeling is not part of your job description, but yeah, show it off a little bit.
Why not? Yeah, that's like great job by the team. I think
pretty cool. Form fitting.
Yeah.
Flattering cut.
Yeah.
Hopefully we can make those get those tees out to our communities pretty soon.
Yeah, that would be amazing. I think folks, Flyte swag is really cool. I really like to wear it. Even my wife wears it all the time. So
love it. Okay, let's get going in just a second here. All right, let's get into it, shall we? Welcome, everyone. Thank you for being here. The Flyte and Union team have been so excited to introduce the Flyte 2 vision. We've just been buzzing, waiting for an opportunity to go public and talk about, what we truly believe is the future of AI orchestration. It's a huge moment, not just for us, not just for our community. It's a huge moment in how orchestration is evolving as agents and more complex, long-running AI systems become the norm. There's a demand for a new type of orchestration that meets the moment, that meets the problems, the challenges, the issues that people building those things are facing every day. So we're really excited to share it with you. Let's get into it. First things first. Next slide. Who are we? Why are we here? You're going to hear from Keithon. Keithon is the co-creator of Flyte, as well as CEO and co-founder of Union AI, an AI orchestration developer platform. He's an engineer by background, specializing in building cloud infrastructure and AI platforms. Now he also does modeling. He's helped launch early stage products at companies like Amazon and Citadel and served as one of the first 5 engineers on the Oracle Cloud Infrastructure team. When he was at Lyft, he led the core machine learning team, and it was there in 2016 that Ketan identified something we probably all know, which is a growing disconnect between the development of machine learning models and their deployment into real-world applications, the experiment to production gap. And that insight, of course, is what sparked the creation of Flyte. John Vada is also here. John's a product manager at Union AI, focused specifically on developing Flyte. Before Union, he led the sales engineering team at SafeGraph. His earlier experience includes quantitative trading roles, something that only smart people are allowed to do, in Hong Kong with BFAM Partners and Evolution Capital Management. John also holds an MBA from the Wharton School and an MSE in data science from Penn Engineering, as well as a BA in economics from Princeton University. And finally, who's that? Is that Ellen DeGeneres? Is that who that? Oh, that's me. Okay, great. This is the hardest part, is introducing yourself in these moments. I'm Zach Johnson. I'm the head of growth for Union. Before Union, I worked in growth and product marketing at Grammarly and Microsoft. I also received my MBA from the Wharton School, and I have a BA from Stanford. We're all really, really excited to be here. It's just an absolute privilege for all of us to talk about Flyte 2. So with that, what are we going to talk about today? We're going to start by setting some context, how orchestration is being redefined by modern AI systems. This context is really important because it leads us to the biggest challenges facing builders of AI, ML, and agentic systems. We've really had our ears to the ground talking to people building these things in real time and understanding the challenges that they're facing. Those challenges have really been the foundation for the vision for Flyte 2.0. And here we're going to share the first public demos, assuming the demo gods are on our side. The first public demos of Flyte 2.0. We'll follow it up with what's next and give everybody an opportunity for some Q&A. Okay, so with that, I'm going to pass it over to our fearless leader, the co-creator of Flyte and CEO of Union, Ketan.
Hey, that was a nice introduction, Zach, and thank you everybody for joining. It's my, I've been in the community, seen, working with all of you guys. It's just been a pleasure just to learn about all the things that Flyte has helped solve in the world. And I think this next step is critical. But before getting to that, I wanted to talk more about the evolution of orchestration and why does it even exist. Some people think orchestration is like a new word. It goes out of fashion, comes into fashion, but it's actually existed as long as software has existed. And the reason is it's not a new concept at all, right? Because if you think about any software product, it does not live in isolation. It always depends on other systems. Maybe it needs data from somewhere else, or it needs to wait for some other process to finish for it to work on. Maybe it needs to work on a schedule. And nobody really ever wants to run software manually. You need automation. But as the system grows and evolves, coordinating everything becomes even more important. If you go back to the early days, we used makefiles, shell scripts, cron jobs, business process automation tools to automate things. At Amazon, I remember in my early days, I came in and the entire order process pipeline was automated by a tool called as Herd. And then later on, some other tools came in, like Simple Workflow, etc. In fact, every AWS service today, EC2, S3, whatever, is behind the scenes orchestrated. And the orchestrator is managing tasks like creating buckets and creating new machines, retries, dependency management. In about 2010, the orchestration started becoming part of the open source vocabulary. And this was primarily driven by ETL because the data tools were exploding. And that's where Airflow, Luigi, Azkaban came up. But they were focused on ETL as a workload. And as microservices started growing from the early 2010s to later, microservice orchestration started increasing more in our vocabulary. We needed durable and stateful processing, as microservices are often defined as stateless. This is where Amazon Simple Workflow Service, Uber built Cadence like Simple Workflow Service, that came Temporal, Step Functions, and a few others. They're all amazing and powerful tools, but they're all designed with one assumption. And the assumption behind these systems was that the thing you're orchestrating is already well understood. The logic's developed first, orchestration's bolted on later, and infrastructure concerns are handled entirely somewhere else. But that model starts to break down in more dynamic, iterative environments. For example, ML pipelines. And at Lyft, we started encountering this first. The challenges were very different. These pipelines are heterogeneous, different hardware, different languages, different compute requirements. There's a lot of iteration. Oftentimes, the first idea that you think is never going to make it to production. So you want to iterate and refine your ideas. And when it works, you want reproducibility, tracking, and flexibility to bring in new paradigms and platforms into the system. This is what led to Flyte. And that idea was simple and powerful, right? It let users declare their data flow and infrastructure together, and off they went. Flyte would handle the execution, versioning, retry, scalability. It feels very natural to use, which allows teams of engineers who are not really, day-to-day job is not really managing infrastructure, to move really, really fast. By 2021, we realized that this was not just an ML problem, but an engineering team problem, because we were now building new products which involved ML into the core. So we spun out Union. But today, we are at yet another turning point. Orchestration isn't something we design for ourselves anymore. It's something AI agents are starting to use to pursue their goals, right? They make decisions and act in the real world. Agentic systems like LLMs, agents, planners, they are starting to drive the orchestration themselves. They choose what to do next and maybe change even the directions on the fly. The flow is no longer predictable. Latency and context management is critical. And we need systems, and agentic systems are not going to be working in isolation. We need agentic systems that be able to operate by humans, and human systems that be operated by agents. So this collaboration is the future. And this led for us to start thinking about the problem deeper. And I'll let John explain some of the things that we learned.
Yeah, awesome. So the next iteration of Flyte should really support and ultimately facilitate the future of AI ML orchestration. And this slide just shows a glimpse of what that future looks like. So first, it's dynamic. Agents are going to determine the shape of the workflow, not necessarily just humans, which means the directed acyclic graph or DAG model doesn't fit because you can't hard code a fixed path. So we need something more flexible. Second, it's going to involve a convergence between tools, data, and models, not just chatbots. And I know this community comes from a background of applied classical machine learning, and I think we're going to see a fusion of classical ML and agentic AI, with agents bringing world knowledge to classically trained systems like autonomous cars. Orchestrators should be data aware and capable of running multimodal AI systems. And finally, reliability is still the most critical blocker to rolling out impactful AI systems today. Flyte took big steps to kind of add reliability to that system. I'd say if there's one big value prop that Flyte has, is it adds reliability. But orchestrators need to continue to give AI ML practitioners the tools they need to tame the non-deterministic nature of these models. So durability, observability, and fault tolerance. And so I have like 6 things on this slide. And so these are basically like, I guess, like one of the big benefits of having a large open source community and being a product manager is you get to hear all this great feedback from users. And so on the ground, like we're seeing a common set of challenges emerge across AI ML practitioners. So there are 6 things on the slide. The first 3, kind of the upper left, have to do with the ways in which we needed to evolve Flyte. And the latter 3 are really key superpowers of Flyte that we wanted to keep and enhance. So I'm just going to talk to each one of these quickly. So first, like, DSLs are difficult to learn and maintain. We were hearing from users who are frustrated that they couldn't put a for loop or a try-catch block inside of a workflow. And it was costly and inefficient for us to maintain the large number of workarounds for achieving the desired workflow shapes. Things like dynamic workflows, conditionals, map tasks, failure nodes, spot preemption policies, and many more. So with Flyte 2.0, we wanted to avoid having new users, including AI code authors, learn a custom DSL. So the next one is debugging. Most orchestrators that are not Flyte make debugging difficult by separating compute from orchestration logic, forcing users to debug across multiple surfaces. So Flyte 1.0's integrated approach goes a long way to making debugging easier, but we heard from users that finding failures in complex nested workflows was a challenge. Users also wanted to be able to programmatically react to failures, for example, by automatically rerunning in a container with more memory. The next one, kind of the third and final way we really needed to evolve, was around static execution. So we constantly heard from users that they wanted to express more and more complex workflow shapes, such as dynamic HPO strategies from the world of classical ML, to adjusting resources based on input dataset sizes, and then routing to clusters based on GPU spot availability. Similarly, like agent builders write code, agents operate in loops, and they wait for some runtime condition to be met. And we needed to really rethink the fundamental assumption of statically defined workflows in order to support these new requirements. And then kind of going to a few areas where Flyte stands out and we think it's really great and want to kind of build into Flyte 2. One of them is parallelism, so fan out. Agents and ML workflows alike need to be able to parallelize computations on data and inference in order to perform well. However, most hosted agent frameworks today are still only running single Python VM with no option to fan out over multiple containers. So Flyte 1.0 enabled this with very low friction with map tasks, and we want to improve on this superpower, extending it to support agentic applications. So thinking about, instead of just being able to fan out over single tasks, being able to fan out over entire workflows to kind of greedily complete, and also have those workflows be able to take different shapes in each iteration of the fan out. And then going to the last 2 here. So I'll say next is workflow resiliency, or what our marketing team calls brittle pipelines. I think it's more punchy. Flyte 1.0 raised the standard for robustness in ML pipelines, and we have big shoes to fill. But the most common challenge cited by agent builders we spoke with was the cost and poor user experience associated with restarting long-running workflows from scratch. And we want to bring Flyte's core superpower of durable, self-healing workflows, as well as caching to the world of agents, and also improve it for ML practitioners. And then finally, many workflow tools make it difficult to implement like software development lifecycle best practices, like auditability, dev versus prod isolation, safe deployment. This is another one of Flyte 1.0's superpowers. And version workflows, native multi-tenancy, native integration with cloud provider IAM allows practitioners to safely develop and deploy AI applications and seamlessly roll back when necessary. So when we sort of add the agent building crowd to our user base, and when those users want to professionalize their AI development platforms, we want to make Flyte the best option. And yeah, kick it over to Kate.
Yeah, so as John discussed, we talked to a bunch of people. We started thinking about this internally, and we were like, is this a fundamentally new system, or is it a system that is an extension of what we have been doing? And what we realized is actually Flyte was solving some of the really cool, important problems like durability, reliability, scale. What it was really lacking was dynamism. And that's what we realized is the solution of the problem. We wanted to build a fully dynamic, resource-aware, and durable orchestration platform. And that's what Flyte 2.0 is. I have so many things to show you in Flyte 2.0. I don't think I can go through everything, but I'm going to go through some of the basics. And what we're going to do is do a live demo. But I'll explain some of the problems first. So let's go to the first slide here, Zach. Or John, the next one, please.
I think I'm on the next one, but there may be a slight lag.
Oh, okay. I can explain. Oh, there you go. So the thing that ended up happening is we were writing the DSL, and as we worked on the DSL, we first and saw the power of strong types, compile time safety, ability to visualize the DAGs ahead of time. But we also realized something else. To get the power, we were effectively building a new language. And building a new language comes with its own trade-offs, including slower iteration and steeper learning curve. So we asked ourselves, what's the best way to unlock true dynamism? And the answer was simple. Don't fight the language. Embrace it. We leaned into Python and eventually other languages. And the programming model itself became native, expressive, and open-ended. So if you're already using a real-world language to build your logic, why not orchestrate it with the same language? And to show this, let's jump into a coding demo. I might be sharing my screen. Tell me, Zach, John, if you can see it.
I see it.
Okay. It's a blank screen because we are going to do a live demo and we're going to write it together. So and the amazing thing is I have Copilot loaded in here, so it helps me write quite a bit of the code. But what we're going to do is we are going to square a list of numbers. So it's not a representative problem really, but it's like it is easy enough for everybody to understand. And if you'll notice, we are keeping the type hints and so on. And we will now just simply write the Python code and we'll try to run it locally. It's trying to be too smart. I don't need all of this stuff, but I can just use a list comprehension technique and do map of square of range of n. Did some mistakes over there, but this is a common way of writing Python code, and you can run it locally by simply saying passing the value to it, and let's run it. So this should run. It ran locally. I was able to square the 10 numbers. It's pretty fast too. Now, oftentimes we have code like this. How do we bring it into Flyte? So when we started thinking about it, we were like, Flyte runs on a remote cluster. So Flyte essentially has a concept of environment, which was implicit in the beginning, and we decided to make it more explicit. So now that environment is a way to actually add environment dependencies like resources, images, and it's very smart. It already knows about a lot of things. But you can, like the resources, in the terms of simplicity, you wanted to make it really easy for you to add resources. So you can add number of CPUs, or you can say I want 1 to 10 CPUs. You can say GPUs, and GPU, actually we went to the point of like making sure that we are able to give errors earlier on. So you can even say I want A180 gigabytes, 4 of them, or 8 of them. But if you try to say 9 of them, there is no machine SKU that has 9 A180 gigabytes. So it immediately gives you a linter error. For this demo, I don't really need GPUs. So I'm going to create an environment. And you can now say that I want to apply this environment to every task or every function. Each of these functions will run in a remote container of its own. And we can simply run flyte.init. Actually, this is flyte.init. Till this point, if you just run print, there is no Flyte involved. All the decorators are ignored and just simple Python functions are invoked. So we decided to get out of your way. But if you just do Flyte init, everything gets initialized. And now you can run it and pass the values to it, get the output, and print run.url. It just tries to autocomplete too much. Very eager. And then you can print the outputs. Let's do that. So I'm going to run this locally. You can run this locally, and you can see everything ran locally. As simply as I was able to run it locally, I can kick it off on remote. But in this case, I'm going to init from a config. By default, it will find the config in the usual areas. But if not, I have a config file in my in my root directory in this project. So I can just simply say this. Now, remember, I just wrote the code, ran it locally, and uploaded it. It packaged this environment and ran it remote. I have not changed anything. I have used pure Python code. And if you go here, it's running it. It's already running, it's triggering, and it's doing the square of one number at a time. If you see, it's running one square at a time serially. That's because regular Python is sequential. Flyte 2.0 SDK is now completely async at its core. So if you just change it to async, it will run everything in async. But if you want to stick to sync, you can still use a flyte.map construct, which is like the Python map, but allows you to use a parallelism directly built into the system. So now you can run, and it's going to run things and create a group of things and run them immediately in parallel. And boom, all of them are going to run, and the square is going to return. Cool. So as you see, this is also the machine that I did not have any machines. We run it pretty cheap. We had 0 machines running, and all of them completed, and you can see the outputs. All right. So that's like the first example. And what we saw over here is that you were able to write code in Python, scale it in parallel. It took care of container builds, packaging the code, and taking it all into the cloud. I will go back and find my link. Can we go to the next slide? So hopefully you also saw that it's very easy to migrate code into the system. The second bit is, sorry, can you go to the next slide? It takes a bit, is it, to go to the next slide? Yeah. The second thing is that we often when people scale things to many machines and run things in parallel, the number one complaint they have is we run out of memory in one of these parts. A common example that many people will understand and probably relate to is that when you're training a model, let's say you're training models across 10 different specific areas, queues, regions, whatever. And one of your regions is New York. Another region is something like Cincinnati, Ohio. Very different intensity, very different in amount of data, and hence very different in amount of computation resources required. So it could be GPUs, it could be CPUs, right? Taking a 30 billion parameter model or a 70 billion parameter model, very different resources. So you want to dynamically adjust the resources based on those requirements. So what I did is I wrote up an example, and I will just jump to the example first, start running it, and then explain as we go through it. So one of our users said they had this a step ride. By the way, if you're sharing my screen, yeah, you are. They have a step of resources that they wanted to include, like 200, 400, 600, 1000 megabytes. They wanted to run this training cycle across tens of or hundreds of regions. So what I did is I wrote a simple async function that would iterate through all the memory overrides, apply each memory override one after the other. And then, and if you notice, it's just maintaining the state here locally in memory. So it's very easy to write. And then I just run over it, run async IO gather to gather the data, and let's trigger it. And if there are any exceptions, I check. If there are no exceptions, I fail it. If there are any exceptions, I fail it. If there are no exceptions, I return the result. And one thing I did is to simulate the large training thing. I created this memory augur function that randomly, it's not random, it's determined based on the instance, like the index. It starts running and failing. So in this case, I was running and I put like a concept of retry groups or groups. Groups are a way of easily visualizing things in the UI. So you can create these groups, and you can run things within a group. So if you saw the first one ran out of memory, and you can see it here, it was killed. The second one was run with more memory. And the way that happened is you actually caught an exception, which can be system errors like spot exemption, error, unavailability of resources, or whatever, and then increase the memory because I just increased with the I, and run it with the new override value. And this is all done dynamically, completely based on runtime conditions and errors. And so you are able to react to problems, solve things, and get things done. Because we also realize that in some cases, errors are not really errors. Many people who are using Flyte Map today use like I'm okay with 10% error toleration. So now you can just write it on your own with retry, with exception tracking in the system. If you jump back to the slides.
And John, I think we want to be on the dynamic slide now.
Yeah, yeah. So this was the debug. We want to be on the next one. So just to quickly explain, we saw all of the errors and so on. But one thing you can also do is, of course, you can rerun any task in a debugger. And this was possible in Union prior to in Flyte 1, and we are continuing to keep it in Flyte 2. All right, next one. So yeah, we for demo gods, we had some insurance.
Amazing that it's Google Slides that's giving us problems and not the actual demo.
That's amazing. But through all of this, you saw that how dynamic and reactive the system is. But the true dynamism happens when it's not just loops and if conditions and try. You should be able to determine any function to run dynamically, like tool calling, as an LLM can do. So to illustrate this, I have a really simple agent framework that I have written. I'm going to call it small agent because it's really small, but it's a play on the words and the existing small agent framework. But this framework is not really a framework. It's just a Python code that allows me to dynamically invoke functions. And what it has is I have a bunch of tools that are all marked with tasks. I have a planning system, which becomes like the LLM. It gives me the plan to execute, and an execute function that actually takes the plan and puts it into motion. Okay, and it's literally a loop. While I have things to do, I will keep on doing things. And let's run it. And as it runs, let's talk over it. So the problem I want to solve is make me a peanut butter jelly sandwich. And it's not really easy to make a peanut butter jelly sandwich all at once in parallel, right? First, you have to go get the bread, get peanut butter, get jelly. Then you spread the jelly, peanut, and then spread peanut butter. And finally, you assemble the sandwich, and then eventually you eat it. And that's my agent. It makes the peanut butter jelly sandwich and all the way to eat. And this was done purely, fully dynamically. There is no coded logic of the workflow or so on. It's happening dynamically, and you can change it. And I'll show you some other cool examples later on that we've actually been able to use this concept and really take it to the next level. So that shows dynamism, pure dynamism. Let's go back to the slides. So yeah, again, the demo gods insurance. Let's move to the next slide. And many of you guys who are here, who are from the classical ML and ML engineering would be like, oh, we're talking a lot about agents. But we think the same platform works across agents and ML. And here's an example. I'm going to go from the classical ML world. We can use this platform. Many people use this platform to run large-scale inferencing, large-scale training, large-scale data processing, and till recently running something like hyperparameter optimization or RFE, which is recursive feature elimination, is actually hard in the system because it needs reactively, dynamically fan out. So I'm going to take this and show you an example that runs recursive feature elimination. And going back to my demo here, I have the code that I wrote, and there are a few interesting things that this example is able to do. One, that the image building is now fully layered, and so you can do things like layering. At the top, you'll see that I have created a UV script. I love UV. Shout out to the UV guys. Astral doing an amazing job. The image building system absolutely knows that you're using UV. And so now it's able to parse out the dependencies from the UV script dynamically and build an image for you based on that. This resolves the problem of local and remote parity. So you can run things locally and you can run things remote. The RFE algorithm itself, like get some features, and for it goes through all the features in one at a time. And as it finds the best feature, it keeps it on the side, and it goes to the next set of features, finds the best feature, ranks them by importance, and runs them. I can run it from here, but let me use the UV run script mode in the CLI to show how this works. So I can say UV run pre-release allow, because we are still in the pre-release SDK mode, and you can give it the RFE script, which was this script. And when you give it, it's going to take that. And I currently have the if main, which is actually doing all the work of passing the parameters and so on. You can, of course, the PyFlyte CLI that everybody loves is still there. I'm just not showing it to run. I probably will show it in the end. But you can run it. It's now running the recursive feature elimination system. And it runs many of these iterations in parallel as it trained and finds the feature importance. It's able to remove the ones that are most important and keep them aside. And if you see, like, it's progressing through all the iterations, and we're grouping the iterations together, and it's really gone through like all the iterations, and we have finally come up with the best set of features for this real world example. Oops. I don't think that creates an output. Each one creates an output. So yeah, you can see the best feature that was eliminated within this round. So that shows RFE, but I have many other examples here. We have Optimizer, which does hyperparameter optimization, and it's using Optuna. It's very easy to write a hyperparameter optimizer now in V2. It's literally like 50 lines of Python code. You can also do something like distributed random forest training. You can, of course, do the distributed training using the plugin system that Flyte and Union have, but this now exists as core part of the system. And going back, so I showed you a lot of Python code, and you all must be thinking, oh yeah, this is just Python. Is this really durable or failure proof? And in fact, it is. We've re-engineered the core. And what we have done is created a log of structured play of the entire workflow. And we replicate it across different regions and clusters, and so that you can immediately recover from failures. To demonstrate this, I have to show you an example because it's really cool. It's really exciting to show this of how it just replays and reconstructs the entire state. So jumping back to the examples, I have a crash recovery example. It's a very simple example. Like, it's really hard to simulate crashes. So in this case, what I'm going to do is I'm going to use the attempt number to create a crash and show you how it recovers. So I loop through like a few numbers, and in this case, I'm going to loop through 3 numbers. So let's run that. I'm going to loop through 3 numbers, and I'm going to fail at index 1. And in the loop, you'll see that I'm actually going through the loop, and at index 1, I cause an exception, and I say simulating failure, and you fail. Now in here, you'll see that it actually is continuing to go on, but you see the failure already, and it continues to work despite of the failure. If you click on the attempts, and you can go to attempt 1, you'll see the first attempt, it was simulated failure. So while this is failing, these things are running, right? So they are independently disjoint processes, but also recovering from failures consistently. So this is true, staying true to what Flyte was, and building new durability and reproducibility guarantees within the system. Moreover, we have not given up on DSL. We still think DSL has a fantastic fit for some use cases, specifically with the low memory overhead and the low usage of resources. So we've adapted the model of JAX, where you can decide when you want to compile certain tasks to create a DSL, and that's coming within Flyte 2.0 as well. Going back to the slides, and I don't need to really show this. Maybe I'll quickly show a little bit of the UI, etc. But all of the superpowers
got a little bit of audio issues.
Oh, sorry. Is it okay now? Can you hear me?
I hear you okay.
Okay. Maybe on your network, John.
Okay. Yeah, I couldn't hear you for a second. Sorry.
Yeah, so Flyte V1 always versioned all entities. It was possible to have multi-tenancy separation by dev, staging, and production. and you could declaratively get infrastructure. All of that exists. You can create config, you can get Ray clusters, you can get Spark clusters, you can get distributed training clusters dynamically. You can also do dev, staging, prod, automatic versioning, do service accounts, secrets. All the stuff that Flyte and Union did continue to exist in a fully dynamic variant of the system. And so, okay, to sum it all up, what have we done? Like, what is this system? We are not building yet another agent framework. We love LangChain, Crew AI, Open Agents SDK, and so many others that are doing fantastic work. But when we talk to all our users, they were struggling to get them into a durable, reliable, production-grade deployment. That's what we are solving, and we call this an agent runtime. And so Flyte 2 now becomes a durable agent runtime that you can rely on to deliver long-running, stateful agent. And to demonstrate this, let me show you a couple examples. So what we did is we went to an online place, and we decided to look at some examples and pull them in. So one of my team members actually brought in the Deep Researcher, which was built by Together. Great work by them. And we decided to just pull in and run it on the system. And this is the Deep Researcher. We actually just created the environment, as you can see, and basically put a couple of decorators on the functions. And boom, it became a deep research agent. And just to show this, I have to run it to really, explain how that works. So we're going to run this guy, and I was running it probably prior to the demo for a little bit. So we're going to run this. And the input to it is list the essential requirements as a bulleted list for a developer-focused agent orchestration system. What it's going to do is come up with a research topic. And as it comes up with the research topic, it's going to go and generate the research. And you can see what was the research topic it came up with. Sorry, it's not yet complete. So it's first generating the research topic. Takes a little bit. You can actually see individual progress within a task. I did not even talk about this. We call this a trace. A trace is a way to bring two things. One, introspect a task as it's running, as well as bring determinism to the task. So in this case, the generate research topic now completed, and you can see it says key features of an agent orchestra, common challenges developer face with, best practices. And then it started doing the parallel searches. And as the searches are happening, you can see the results of the searches. It's pretty amazing to see the results of the searches. You can see what are the keys and the top AI agent frameworks, LangChain, AutoGen, Crew AI. It's pretty cool research. And this is Markdown. We are working on automatic Markdown visualizations in the UI, so you should be able to visualize this. You can look at the second search topics, and it came up with a technical guide to agent orchestration with hypermode. And this is just running really with Tably search. By the way, just to go back in here, we used secrets. Wara has, thankfully given us his secret keys to access the Together APIs and the Tably key. So we are using both these services.
More, so you're welcome.
Yeah. So we can run these things, and they just show up as things are running. Each one of these traces are inside a function. So just to show you the code, inside the function, we can have things like traces. Let me see. I have to go in here probably to see the tools, and some of the tools have traces and so on. That's the trading agent. Where is my other agent? Has to be somewhere here. Yeah, of course, I'm not finding it. But some people have we have decorated certain things with traces, and they just show up in the UI. Another interesting agent, and we have a bunch of these, and it'll keep on running and finally generate a PDF, and you can see it. Another interesting agent is a trading agent. And this is not a single agent. And we can probably run it. I was not going to, but why not? Okay, so I'm going to just run uv run pre-release allow and main.py. So what that does is creates a dynamic environment and triggers off the trading agent. In this case, if the image was not built, so this is amazing. It's going to show you that the image needs to be built, and it's going to build the image dynamically. We are open sourcing the remote image build protocol as well as part of Flyte 2.0. So all you folks can build the same image build system as us at Union, which comes pre-hosted, etc. And so it'll take a little bit to build the image. There are a lot of dependencies, but as it builds the image, I will probably find an example if I have one here. Let's call it the trader. Yeah, so the trading agents, these ones were failed, but you can go back in time and see like how they failed. Yeah, we were actually, the place at which we were failing was basically we were using the new S3 vectorized buckets to store the data. But if you can see, we are running multiple agents. One, there's a stock trader agent, there's a market analyst agent, and so many other agents. And this was not built fully like from scratch. They actually took most of the LangChain code and just re-implemented the agent using the system. Just migrated the agent to the system. And this is LangChain code as is without many changes. The only change we have done is put decorators on the tools. And so that's how it works. All right. Going back.
Nice.
Yeah.
Yes.
So John, why don't you take over and walk through like what's coming today and what's coming next?
Yeah, amazing. And yeah, just to kind of point out on the agent example, we're because we run Python, it's native Python, and because we can just import an agent framework into like a driver task and run it, and then the tool calls are just Python functions, which can be also implemented as Flyte tasks like really easily. We can just natively support like give you that durability, observability, caching, accessibility of your input and intermediate state, so that you can build a reliable system using those tools. So we thought that was super cool. Just want to talk a little about the roadmap. So today we're going to open source the Flyte 2.0 Python SDK.
I think John, we're losing John a little bit. So maybe I'll explain. So we are going to open source the Python SDK today with docs, some examples. We will work with the community to actually get more examples in. We are open sourcing a couple plugins built into the SDK. The most important ones like Ray and Spark and distributed trainings coming very soon. And all of this is based on the Rust core, and that's getting open sourced as well with the SDK in the next week or so. Next comes essentially all our plugins, as I said, compile tasks that allow you to create DSL directly out of regular Python functions. And I think maybe John was also sharing the deck. And then Zach, can you share, or should I? I can share it too. Okay. I should.
Yeah, why don't you? You're already connected.
Yeah. All right. Cool. No problem.
Presentation mode too.
Yeah. Sorry. So then comes compile tasks and the migration guide. We do not, like, if you are thinking like, oh my God, Flyte 2 and how will we migrate? Everything will be migrated automatically. And in the 99% cases, there will be 1% case that you might have to change, but the change is very minimalistic. And so because Flyte 2 is a superset of Flyte 1. And 3 comes a local sandbox that you can start trying and testing everything, and then comes a full OSS beta with automatic migration built into the system, and then comes the full GA of the system.
All right. So I want to jump in here quickly. I promise there's a great reason why I'm going to give you a quick overview about Union AI. Union, we're the company that maintains Flyte. Stick with me because there's a really cool opportunity at the end of this. So Union is an end-to-end AI orchestration platform designed to solve the experiment to production gap. It takes an optimized engine, optimized compared to Flyte, compared to any open source solution, for orchestration, adds in real-time inference and observability through a cost allocation dashboard, data lineage, etc. The Union control plane will orchestrate data models and code securely in your cloud. So it's a bring your own cloud type thing, along with the enterprise features that you'd expect, like SSO, RBAC, and direct support from our team. Why am I telling you this? Because on the next slide.
But before that, I know the next slide is this, and I'll keep it, and please use it. I'll come back to this. I know we are running out of time, but I couldn't help myself. I wanted to show a quick demo of what we can do with this system today. What many people have not realized is possible in the system. One of our users came to us and said, like, we want to do something that's really real time and the overhead has to be minimal. And so we kind of built this small demo. They were reading from a queue and reacting to things happening from a queue. So let's go, and I'm going to quickly show. I actually asked Claude Code to write me this code. It wrote a processor that reads from a queue all the data and runs things one by one, and it just uses async IO create task, but it runs that as a remote process in the process message. It extracts the word that was sent in the message and shows it in the UI. So let's run this guy. And as it runs, of course, so it's going to run here. And I'm going to move it to the side like this. And I'm going to use this split screen mode to show something really cool. So this is using a queue that's running in my system. And I can actually send data to it from my local laptop. So I'm going to send like 10 messages from my queue from here to my local laptop. And as you see, as the messages are sent, they're immediately processed by the system. So for example, you can look at it. The first message was waterfall. The last message was banana, and so on. And if you see like it's going to do 10 messages. And let's rerun this thing again because it's fun. And I'm going to show something fun. Like this is really reactive. You can send one message per 100 milliseconds, and you can see they just appear rapidly on the system. And this changes what you can do with the system. Sorry, I had to show this. Back to the...
Okay. Well, I mean, the important thing to know is not only was that demo live, all the Flyte 2 demo work that you did was live in Union today. So we have an opportunity here. We are gathering interest in a private Union beta where Flyte 2 is live and usable today. You can go to union.ai/beta to express your interest. You can scan the QR code. We're really excited to bring in strong partners to start using Flyte, contribute to the vision, and help us build the future of AI orchestration. With that, I've been monitoring the chat. There are a lot of great questions in the chat. So I think the next slide, Ketan.
Oh yeah, sorry, Q&A. I forgot.
First of all, take a peep at all the different URLs there to stay in the loop. The two most important ones being there at the top. I'm not sure if the SDK is officially published on GitHub yet. If it is, that's the link. So I'm going to grab some questions.
Also star the Flyte repo, guys.
Oh, start the Flyte repo, absolutely.
Yeah. And join Flyte.org, participate in the discussions, ask questions. We are happy to help.
Okay, Brother Peter says, was that Union Cloud specific Flyte UI, or will that also be the new UI coming up for open source self-hosted versions?
That is a Union specific cloud Flyte UI. Sorry, it's not Flyte, it's like Union UI. A part of it will be coming to open source. Like the entire system has been made stream first underneath, and we will be open sourcing some portions of that UI. Absolutely.
Okay. Another question from Bogdan. What's the Kubernetes support like?
By the way, yeah, this was all built on Kubernetes. This is not using any custom orchestration solution. It's all on top of Kubernetes. Yes. So you can.
And to add, the open source, we've been demoing Union. there will be a self-hostable, open source Kubernetes-based backend for Flyte 2 the same way that it exists for Flyte 1.
Another question from Bogdan: can we still host the execution engine?
For Union or for Flyte? For Flyte, absolutely. For Union, yes, also.
For Union or for Flyte, the answer is yes.
Yes, but Flyte's open source. It's not available today. It's coming.
We have another question. I'm curious how the Flyte system recovers from failure. Can you talk more about it? For example, if the Python code's working with an in-memory queue, how does it even figure out the state and recover from there? From somebody new to Flyte?
Oh, a fantastic question. The way it recovers, it relies on deterministic behavior within the code base. And it's not always possible to build in determinism, right? And this is where we have a concept of trace. That's the only second concept in the system. There's actually environment, task, and a trace. A trace is a very lightweight function decorator that allows, it's like an LRU cache of some sort, right? That allows you to memorize the behavior of a non-deterministic function, and it records it. So that if you replay in the same sequence, the same function, it just replays from memory. And the memory is stored to a remote environment like S3 or databases and so on, and that cache is replicated. And whenever the system fails and recovers, it just gets back the same point.
And real fast before you move on to the next question, Kathan quickly highlighted something called traces in the UI. And those are a way of, without creating a new container, just memoizing the output of a helper function in the same state store. And so that's a way, think of that as a way to call an LLM or any sort of non-deterministic function securely, and also like add recovery in like a more granular way to your functions.
Yeah. One other thing I'll say is that, by the way, the entire demo was just using S3 as the backing meta store. We have capabilities of switching out the meta store with a much faster engine store, but as you saw, it's pretty damn fast. Next one.
All right, Broder asks, any chance there are rough time estimates for the milestones?
Or did I miss those as I was still amazed? Thank you for being amazed by the features. But actually, the interesting thing is we actually don't have new features. We have actually cut down features. It's just what you can do with Python. The estimates are, as we go throughout, we have to go through the entire community, make sure that the system is stable with the open source components and so on. We think it might end up towards later this year.
Yeah.
All right.
And we didn't want to put that on the slides, but we commit to having a plan for a plan, and we're going to give like clarity as it becomes available around that. So thank you.
And as a reminder, Flyte 2, as you saw it, is available today in Union. So if you want to participate in our private free charge beta, please express your interest at union.ai/beta. Okay, we've got time for.
We have to answer
a question.
Yeah. Any potential change? Nope. No changes in open source. It is an Apache 2.0. It is part of Linux Foundation. It is being donated to Linux Foundation basically today. And we think a system like this needs an open source programming model, and we would love for all of you guys to share the word and get more people using the platform. And that's how we grow. We have 3,000 companies in the world using Flyte today. We want to get to 10,000 companies. Let's go.
Let's go. How about 100,000?
Yeah, let's go to 100.
All right. We've got a couple lightning round questions in the last minute. So let's answer these in like 10 seconds. The async tasks look like main was a container spawning other tasks. Does this mean all tasks are fully composable cluster aware now?
Oh, that is absolutely right. We still have reference tasks. We have tasks. All of that exists. Like, yeah, I cannot show all the features, and you can spawn to specific resources. Absolutely.
Awesome. So with Flyte 2.0, you said it supports long-running stateful agents. So it supports microservice deployment now along with batch?
It does bring up the cluster, like the logical cluster on which things are running dynamically, right? That's the power of Flyte, and we want to keep it. It makes it serverless in your Kubernetes cluster. It is not microservices, but it does work like microservices, like really lightweight and fast.
Okay, last question before we end here. Does Flyte 2.0 support setting workflow priority?
It is coming soon. As part of the redesign, that is absolutely in the protocol buffer. The implementation of that might depend on your Flyte deployment. With Union, we will be supporting out of the gate.
All right. That concludes our session for today. Thank you, everybody, so much for attending. Remember, you can express interest in private beta at union.ai/beta, and you can preview Flyte 2 open source with the SDK, which is at github.com/flyteorg/SDK. Follow us on LinkedIn for regular updates and participate in our planning and vision. Thanks, everyone.
Thank you, guys. Bye-bye.